All right, this is the GACE 022 ETS Practice Test, and we're on question 19. It asks you, well, you're looking at a piecewise defined sequence, or actually it's piecewise, but it's also recursive. And it wants to know which one is a closed form representation of that sequence. In other words, which of the ones below are the same as this one. So this is what I am going to advise. We are going to, first of all, this piecewise defined function, I want you to notice that it's saying that you start when you're at n equals 1, the answer is 1. So I went ahead and put this over here because at n equals 1, it's saying that you know that a sub n is 1. Okay? Then it says, and this is all this means, it says if, for any others basically, you look at the a sub n before it and add your current n value. Okay? So for any of the others, so you look at the a sub n, the answer that came before it. So right here, to figure out what goes right here, I take the number that came before it, which is 1, and add my current n value, which is 2. 1 plus 2 is 3. And I do the same thing for the next square. I take my a sub n before, I don't know why it keeps doing that. I take the a sub n before that, which is 3, to which I add the current n value, which is 3. 3 plus 3 is 6. And you continue to go that all the way down. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. I'm just going to go ahead and finish since I already wrote these out. 28 plus 8 is 36. 36. I'm getting very irritated at this computer. It keeps jerking it over there for some reason. 36 plus 9 is 45, and 45 plus 10 is 55. All right, so I know that those are my values. And so now all I'm going to do, if it's a closed form, then I can put those equations into the calculator. So I'm going to pick up the calculator, and I'm going to see which ones in a chart, which one or ones in a chart will actually equal the same as my results. So keep in mind that when I am putting these in here, that I can't use an n. I have to use x. That's the only variable that this recognizes. So I'm going to enter x minus 1 times x. Now I'm going to back up here. That's an entire numerator. So I'm going to enclose the entire numerator in parentheses and then divide it by 2. As you see there, you could do divided by. Generally, my rule of thumb is entire numerator and entire denominator I put into parentheses, which is what I've got there. And I hit OK, and I'm going to do the next one. The next one, and remember that I always do these in Roy G. Biv color order so that I can see them. So the next one is n plus 1 over 2, so entire numerator, n plus 1, divided by entire denominator, 2. And click OK. The next one, I'm going to make yellow, even though I'm going to look at the chart, but you'll see. Open parenthesis, n times, open another parenthesis, n plus 1, close the n plus 1, close the numerator, divided by, open the denominator, 2, close the denominator. Okay, and the last one is, the fourth one is, okay, here we go, n squared. Oh no, hold on, forgot something. Let me cancel this. I did exactly what I said don't do. You can't put n in here, it doesn't know what that is. Okay, and I need to fix this. X, X, okay. And I think that's good. So now I'm going to go to green, the last one, and it's going to be x squared minus, open parenthesis, x minus 1, close parenthesis, open parenthesis, x plus 1, close parenthesis. Okay. They're all four in there, so I'm going to look at the table now. I'm going to start at 1 because all of these sequences have to start at 1. And the step is going to be 1. And then I'm going to take a look and see which of these in the Y value. So this is the red one, or selection A. This is the orange one, selection B. The third one is selection C, and the fourth one is selection D. And looking at selection D, actually, if you look at that, if you were to multiply n minus 1 times n plus 1, your n would go away completely, which is why it's constant. I'm looking for the one that is 1, 3, 6, 10, 15, 21, and so on. And if you look, that's the third one. So that was answer C. So I am going to zoom back in, and that's the answer, C.